Hello, welcome to chapter 12. We're going to explain about the clusters we've been doing, about tensile stress, tensile strength, Young modulus, and surface tension, and those kind of stuff. Okay, let's start with the question number one. So question number one is stated that the tensile maximum stress means the maximum stress of a steel it can handle is 5.0 times 10 to the power of 8 pressure for Pascal. The Young modulus of steel, so highlight Young modulus of steel is 2 times 0 times 10 to the power of 11 Pascal. When the main engine of a space shuttle are fired, they develop a total thrust of 4.5 times 10 to the power of 6 Newton. In a testing firing shuttle is held to the launch pad by 8 steel bolts. Each diameter of this one, calculate the strain. Okay, so first thing first, we need to list down everything we got. So the maximum stress we got, maximum stress, it's not that the current stress we have, but the maximum stress of steel that we can handle is, so this max, okay, stress max is 5.0 times 10 to the power of 8 Pascal. And what we have Young modulus. So Young modulus E, Young modulus we have is 2.0 times 10 to the power of 11 Pascal. And when the main engine is however total thrust. So the force of this scenario experienced by the total bolt is 4.5 times 10 to the power of 6 Newton. Testing fire held by 8. So number of bolt is going to be 8, and the diameter for as a D is 9.0 times 10 to the power of negative 2 meter. So this is all the information that we have. Okay, all the information that we have, and we're gonna solve it using this. So first, you want to find strain. So before finding strain, we know that the Young modulus formula we have is stress over strain. Strain is E. Yep, stress over strain. So in order to find strain, we need to have a stress divided by Young modulus. So we already have Young modulus, but we don't have the strain. So for the total force we have is this one, the total force. But for each bolt experience, how much? For each bolt. So when you calculate for the force for each bolt, we need to be force for each bolt. It's going to be 4.5 times 10 to the power 6 divided by 8, and we got our number of 5.625 times 10 to the power of 5 Newton. So this is each the force for each bolt. So we have the force. How about the area? So we can calculate area. So area is actually pi r square, or you can change to pi d over 2 square. Okay, so we just substitute everything inside. We have the pi, we have the d of 0.09, 0.09 divided by 4 square, and the answer we got here is 6.36 times 10 to the power of negative 3 meter square. Yeah, meter square. So we have the force. Okay, so we can calculate the stress of each bolt. So stress of each bolt will be this one, force over area. So for the stress is 5.625 times 10 to the power of 5 Newton divided by 6.36 times 10 to the power of negative 3. And the answer we got over here is around 8.84 times 10 to the power of 7 Pascal. Okay, so in order to find strain, so we have force, we have stress, and we have Young modulus. So the formula will be 8.84 times 10 to the power of 7. So this one will be strain divided by stress, divided by Young modulus, which is 2.0 times 10 to the power of 11. So the answer we got over here is 4.42 times 10 to the power of negative 4. So this is strain. Strain doesn't have unit, so this is the answer. Okay, so in order to find one another, you just need to substitute everything we have. Okay, so we starting with the force for each bolt, and calculate for force for each bolt, and we calculate the area, and we can find the stress, and we use the formula over here. Okay, in order to find the strain. Okay, in order to find the strain. So this is how we find the strain for the number. Okay, so how about the next question? The next question, the minimum number of bolts. The minimum number of bolts. So currently this one is how many bolts? Is 8 bolts considered for strain on each belt is this one. Okay, how about how to find minimum? So first thing first, we also need to find the other part is find the maximum force we can experience. Okay, so the maximum force that we can experience for each bolt is how many? So if the total force is this much, we just divide it, we can find. Okay, so for example, force max for each bolt is actually stress times area. So the stress formula stress we already have is 5.10 to the power 8, and area we got it over here is 6.36 times 10 to the power of negative 3. Okay, so this is what we have is 3.18 times 10 to the power of 6 Newton. So this is maximum stress for each bolt. So but the total stress we have is over here. So we just divided it. Okay, so we divide it. So number of bolt equals those total stress, okay, divided by total stress max force, sorry, isn't the total stress is the max total force, sorry, total force divided by max force each bolt, and we got our answer is 4.5 times 10 to the power of 6 divided by 3.18 times 10 to the power of 6, and we got answer is n equals to 1.42. So 1.42 is equals to lah, so roughly just two bolts required in order to handle everything lah. So this is the answer for the question 1, part 1 and part 2. Okay, so this will be part 1 and part 2. Okay, let's go to the question number 2. It says that a gymnastics performing a balanced position support, okay, supported by both arms, okay, the bone of each forearm have length this one. The total cross section of the bone is at both forearm. So total cross section means each bone added together is this one. Okay, so we don't need to divide by 2 because this is towards the total area already. Okay, the mass of gymnastic is this one. Yeah, this one. Okay, this one doesn't ask what is the question, but assume I asking the question is about strain. Okay, assume asking about strain. Okay, strain or how much it extend lah. Okay, for this question we can do it like this. We just list out everything we have. Again, for the length is actually 0.25. Okay, and the area is given us is 1.2 times 10 to the power of negative 3 meter square, and also the genus mass is 50 kg, and we can find force is just 50 times 9.8 because force equals ma. Okay, force equals ma, we got is 490 if I'm not mistaken. Okay, and the Young modulus for E is 1.6 times 10 to the power of 10. So I just list out this is not kg, it should be in pressure, so it's Pascal, and maybe want to find is change of length. Okay, change of length, how many? So what we have this. Okay, so again we're using the formula we have is for example Young modulus, which is E equals to stress divided by strain. Okay, stress divided by strain. So first thing first, we want to find strain in order to find the change of L. Okay, because change of L is equals to alpha, but we don't have alpha, right? Yeah, so maybe the answer should be just to find the strain we do, because we don't have change of L. So strain is how many? Okay, so let us put inside everything we have. Okay, so let's put everything we have. Oh, I think we can still find it. Yeah, everything we can find it. Well, just let us do it and see. Okay. For Young modulus we have is 1.6 times of strain is put in one side, and stress divided by Young modulus is equal force over area. So the force we have is 490 divided by area is 1.2 times 10 to the power of negative 3, and divided by the Young modulus, which is 1.6 times 10 to the power of 10. And this get us the strain will be 2.55 times 10 to the power negative 5. Okay, so we know that the formula of change of L equals to what? Change of L equals to this one, alpha L, and change of T, right? But change of L over L is also strain. So if you want to change of L, you have two-time formula, so we use the one that below. So change of L divided by 0.25 equals strain is 2.5 5 times 10 to the power negative 5. So change of L is equals to, we just times it, which is 6.4 times 10 to the power of negative 6 meter. Okay, so it's extend 6.4 times 10 to the power of 6 negative 6 meter, or in other words it's millimeter lah. 6.4 micrometer, not millimeter. Is it millimeter? Yeah, it's millimeter. No, it's micrometer. Yeah, it's micrometer. Okay, it's micrometer. Okay, so this is the answer for this question. You just need to understand the formula, okay, and using this formula, because there's two of them, but we know we're using the one below because we are in order, we have the strain, and in order we can find the change of L. Okay, so this is question number 2. So let's go into question number 3. So the step is the same. You just need to figure out what is the main point, the main things that it gave us, so we can understand how to do it. Okay, a steel plano wire, diameter of this one, so give a diameter and length of this one. Okay, when you tighten, it emit a not require the frequency extend by this one, so this one is just change of L lah. The Young modulus will be this one, and calculate the strain installed. Okay, so we just list out everything down so we can understand. Okay, so it listed the first thing, diameter, so D is 1.8 times 10 to the power negative 3 meter. Okay, the next thing is telling us is L, so L is 1.55 meter, and extend, so this one change of L is 1.3 times 10 to the power negative 3 meter. The Young modulus E will be 2.1 times 10 to the power of 11 Pascal. Okay, first you want to find strain. So strain, the formula for strain is what? Strain, the formula is change of L over L. Okay, so the change of L is 1.3 times 10 to the power of negative 3 divided by 1.55, and we got is 8.39 times 10 to the power of negative 4. So this is the answer lah for strain. Okay, so we got this. Okay, how about the second question? Calculate the force. Okay, so in order to find the force, we know that the formula for force is, we can find is E equals stress over strain. So we can find stress first in order to do that. Okay, so how we find stress? So stress is actually E times extension, not extension, is strain. So we can get is 2.1 times 10 to the power of 11 times how many? Strain is 8.39 times 10 to the power of negative 4. So this is our answer for stress, is 1.7 times 10 to the power of 8 Pascal. Okay, so but what we are finding is not stress, but we are finding the force. So what is the formula for force using stress? So stress is force over area, and we know the area is actually pi r square. Okay, so force pi r square. So this one, area equals force. So this one is 1.7 times 10 to the power of 8, and pi r square, pi r, you don't know r, we are diameter, so 1.8 times 10 to the power of negative 3 divided by 2 square, and it equals force. Okay, so this, we substitute everything, we can find the answer. So answer for this one, force is around 447 Newton. So this is the answer for this question. Okay, so this is the answer for this question. Okay, again, very similar. We know that the formula for strain, no formula for Young modulus, stress, and Young modulus formula. So we can just substitute and can find the answer we want. Okay, easy. Okay, let's go into question number 4. So the question number 4 is a bit different because it's what they're asking is what is the excess pressure inside the centrifugal drop of radius of 1, I think it's 1 centimeter lah. I don't think it will be 1 millimeter, but 1 centimeter. Okay, so how we going to find it? 1 centimeter, and the surface tension of water is this one, so it's giving surface tension. So we know that we need to use the formula for the surface tension. Okay, but in order to find the formula for the surface tension, okay, I just listed out the formula for surface tension. It will be T equals force divided by length. Okay, but there's a lot of things we did not have. But so how are we going to find it? First thing first is we need to find about pressure. So we know that pressure is equals force over area, right? So pressure equals force over area. So we know that pressure times area equals force. Pressure times area equals force. So we can substitute inside. Okay, so we know that force equals tension times length, and force is actually pressure times area, and tension, the length is how much? The length of the surface area is going to be 2 pi r lah. Very simple for a spherical drop. Okay, because it's a drop, it's not a bubble, because bubble have two sides, you need times 2. Okay, so if the drop is just outside, but it's a bubble, we have two layers, so inside and outside. So there's a difference between that. If just a spherical drop, it's just one side. Okay, and this is it. So for one side, and pressure is pressure, because we need to find pressure. Area is going to be pi r square. Okay, is T 2 pi r. Okay, and we're going to shuffle around. Pressure is going to be surface tension divided by times 2 divided by r. So this is the formula we have. Okay, so this is the formula we have. Okay, so and basically it's just very simple. We just need to substitute the things, then we can get an answer. So what do you have? The radius of 1, I think is 1 millimeter. Sorry, not 1 centimeter, 1 millimeter, 1 millimeter radius, and the surface tension is 7.3 times 10 to the power negative 2. So we substitute inside. Pressure equals to 7.3 times 10 to the power negative 2, and the radius is 1 millimeter, so 1 times 10 to the power negative 3. Then we got our answer. Our answer is 1.746 times 10 to the power 2 pressure Pascal. Okay, so this is the answer. So very important, we need to understand, we use the things that we know. So tension is this one, and the length we got is only 2 pi r. Why? Because it's a drop, so which is the outer layer, the inside layer doesn't have any. Okay, unless it's a bubble. So it's not a bubble, so we just have one outer layer, contact area. And the second one is the area, is this one. We're using the pressure equals force over area formula. Okay, so this is the answer we got. Okay, let us go to the final question. Let's go to the final question. So a U-shaped wire frame have a light sliding rod connected with 2 vertical arms. Okay, so this one, 2 vertical arms. The frame dip into a soap solution, then held horizontally, forming a soap film. The sliding rod, mass of this one, length of 20 centimeter. The surface tension of soap is this one, and the rod is resisted as time 0. Assume there's no resistance. Find the velocity at rod at this one in km per hour. So again, we need to list everything. So first, mass. So mass is just 0.1 kg, and the second thing you have is length, which is 0.2 meter. Okay, and the surface tension is going to be 0.05 Newton meter negative 1, and last is time is t equals 5 seconds. Okay, first thing first, we need to use the formula, and it is surface tension equals force over length, but because it's two side, okay, so it will be length equals times 2. Okay, so we got force equals tension times length. Okay, so the tension will be 2, tension is 0.05, and length is 0.2. Okay, then get the force is 0.02 Newton. Okay, so first this one find force. So force equals what? Force equals mass times acceleration. Force equals mass times acceleration. So we have the force, and the mass we have is 0.1, and we can find the acceleration A. So this one is, you change it to 0.02. Okay, acceleration will be 0.2 meter per second square. Okay, 0.2 meter per second square. So for time equals t, find the velocity. So it's very simple. You know, v square, no, not v square. Okay, v is equals, I write in another place so we can see you more clearly. So v equals u plus at. So each starting doesn't move, doesn't have u. So v is equals what we want to find, and a is over 0.2, and t is about 5 seconds. Okay, so after that we can find is 1 meter per second. So 1 meter per second convert into km per hour is going to be just times 3.6. So convert into 3.6 km per hour.